Given the one-to-one function f of x equals x minus 3 entire quantity raised to the 5th power, find f inverse. We'll go through our 5-step method. Step 1, we'll replace f of x with y. So y is equal to x minus 3 to the 5th. Step 2, that's where we solve for x. We're going to get x alone on the left side. The first thing we need to do is get rid of that 5th power because x is locked inside of that. To eliminate the 5th power to this equation, we're going to raise both sides to the 5th root. And we don't have to do plus or minus because the 5th root is not an even index root, like a square root, a 4th root, a 6th root. If we did that, if we took the square root of both sides, we'd have to do plus or minus. But the 5th root is an odd index. 5 is an odd number. So we don't have to use any plus or minus. Take the 5th root of the left side, and that's equal to the 5th root of the right side. And the 5th root of the right side, we have the 5th root and the 5th power canceling one another because they are inverse operations of each other. That's exactly why we took the 5th root. We're trying to get rid of the 5th power. That leaves us with the 5th root of y is equal to x minus 3. So now in our attempt to isolate the x, which is step 2 that we're working on, we need to move the negative 3 over. We'll add 3 to both sides. We get the 5th root of y plus 3 is equal to x. Now we're going to turn it all backwards because we wanted to isolate the x on the left side. So we get x equals the 5th root of y and then plus 3 outside of the root. Remember that 3 is outside of the radical. That's why I hooked the radical down after the y. Now we move on to step 3. Step 3 is where we rename the x and the y. So we get y equals the 5th root of x plus 3. We just swap the names x and y. And then step 4, since we were told that this was a one-to-one function in the question, we know that we can replace y with its fancy inverse function close. We replace y with f inverse of x equals the 5th root of x and then plus 3 outside of the radical.